Hello, students. Mr. Odom again. I hope you guys enjoyed that deductive reasoning worksheet. I'll go through that today and kind of look through those and get those graded for you. My grading policy is pretty straightforward, guys. Just work hard on it. Give me some basic information, and then we'll get along just fine. So today, here's what's going to happen. I'm going to send out the text for Chapter 1. It's out of the book that I scanned in the copier, so you should get a text of it, a PDF of it. And then I'm going to go ahead and do this screencast for the first half of that text, talking about the history of forensic science and then what's the three major roles of a forensic scientist. And then I'm going to have you guys go through that the rest of this Google slide. I'm going to make a copy for you, send it to you, and then I'm going to have you fill in some stuff on the rest of the slides and then submit that back to me for your assignment. Okay, so I'll give you half the notes. You got to give me the other half. All right, so what is forensic science? By definition, it's the application of science to those criminal and civil laws that are enforced by police agencies in a criminal justice system. All right, so a bunch of fancy words here. The application of science, and we're talking about all branches of science, everything from chemistry, astronomy, if you need to use astronomy, any branch of science that can somehow be tied to a criminal or a civil case can be used in a court of law. That would fall under the auspice of forensic science. Now, what's the difference? Criminal law are those court cases that try to solve crimes. Okay, you have to prove beyond a reasonable doubt to 12 juries, 12 people, peers on the jury, that the suspect is committed the crime. A civil case is on the financial side. There's what we call the preponderance of evidence, which basically says, all the evidence points that you did this. We're going to hold you liable financially. Now you have to settle out of court, or we're going to award the victim's money. So in the O.J. Simpson case, he was acquitted of first-degree murder in the criminal court. Okay, but he was found guilty in the civil court and had to pay $33 million to the families of Ron Goldman and Nicole Brown Simpson. He hasn't paid any of that $33 million, but that's the civil case that he lost, but he won the criminal case. So it's applied science. We also call it criminalistics. Okay, when you look at the criminal, what we're doing with this applied science towards the criminal justice system, it's basically the science behind the criminal justice system. And if you watch shows like Forensic Files and CSI, those are a little bit more dramatic than the actual process, but the science is still legit. Okay, you're still talking about scientific method. You're talking about using technology. You are applying what you know in science to the criminal justice system. All right. So what are we talking about? What kind of branches of science are we looking at here? Again, using chemistry, the branch of chemistry, whether it's organic chemistry, the different ingredients of certain chemicals. There are devices out there that you put a chemical into it, and it will tell you the exact percentage of every single ingredient in that chemical. That's important because a lot of times, certain industrial agents and certain industrial companies will only use a certain amount of chemical in each one of their products. So you're able to kind of work backwards and go from product back to the industry to the company when you have some of these products. Biology, using bugs to solve crimes, using what you know about the certain types of wildlife in the area and certain bite marks and things like that. Okay, physics. If you're on the scene of a car crash, the size of the car, the momentum the car might have been traveling at, the length of the skid marks will tell you how fast the car is going. So using the math and the physics behind certain crimes will help you in the civil and criminal court case. And geology, if you're a forensic pathologist or if you're an anthropologist and you're digging up bones, knowing the different types of soil layers you're in, the different types of soils will help you understand how the body might have decomposed or how the body got there. Okay, sometimes you'll have a crime scene where a body's been dumped. Okay, but let's say that body's covered with different types of rocks that aren't native to where the body was found. So now you have a clue, a geologic clue, with all these different types of rocks that may or may not point you to a different direction or the primary crime scene. All right, well, let's look at some of the history of forensic science. There's several scientists that really led to where we're at today with all the massive databases we have and fingerprint databases. So let's look at some of these scientists here. I'm going to start with Matthew Orfila. He seems to be the father here of modern forensic science. 1787 to 1853. What he's doing is he's looking at the detection of poisons and the effects of poisons on different types of animals. Okay, so he starts this idea that, we know that there are different types of poisons out there. We know that they have effects on animals. Do they have an effect on people? And if so, can we use that kind of idea of detecting these certain types of poisons in people, in animals, to maybe solve a crime? Okay, so he's really, he's just kind of looking at how to detect certain types of poisons on the effect of animals. So he kind of starts this whole revolution of forensic science, but it really doesn't get started until Sir Arthur Conan Doyle in 1887 published a novel called A Study in Scarlet. Okay, this author, Arthur Conan Doyle, invented or developed the fictional character Sherlock Holmes, and everyone knows who Sherlock Holmes is. Fictional character, one of the greatest sleuths and detectives of all times. But what's unique about Arthur Conan Doyle and his Sherlock Holmes character was, he used deductive reasoning for sure, but he's also starting to use branches of science in his character. Okay, so here is a brief excerpt of one of his novels in 1887. I found it, he shouted to my companion, running towards us with a test tube in his hand. I have found a reagent which is precipitated by hemoglobin and nothing else. Why, man, it is the most practical, medical, legal discovery for years. Don't you see that it gives us an infallible test for bloodstains? The old Whatcom test was very clumsy and uncertain. So is the microscopic examination of blood corpuscles. The latter is valueless if the stains are a few hours old. Now this appears to act as well whether the blood is old or new. Had this test been invented, there are hundreds of men now walking the earth who would long ago have paid the penalty for their crimes. Criminal cases are continually hinging upon that one point. A man is suspected of a crime months, perhaps after it has been committed. His linen or clothes are examined and brownish stains discovered upon them. Are those stains bloodstains, or mud, or rust, or fruit, or what are they? That is a question which has puzzled many an expert. And why? Because there was no reliable test. Now we have the Sherlock Holmes test, and there will no longer be any difficulty. Okay? So the idea that technology starts to advance to solve crimes by developing reliable tests that are scientifically valid, that's a big point, scientifically valid, and a prosecutor can use them in a court of law. He starts this whole process here by a fictional character. Matthew Orfila took it a little bit step further here with his, kind of started with detection of poisons. The next guy, Alphonse Bertillon, okay, the father of modern detection, and he develops a system called anthropometry, which is very unique. When you look at our criminal science databases now, every fingerprint is probably, if you've ever given a fingerprint, it's in a database. It's stored somewhere. Your DNA, if you've ever given DNA, it's stored somewhere. Every fiber of every carpet is stored in a database somewhere. There's something to compare it back to. Alphonse Bertillon kind of started this. What he was doing is he was taking prisoners and people, and he was measuring body parts. Okay, the size, the width of the forehead right here. Okay, or the size of your foot, the size of your big toe, the width of your foot, the size of your head from the top to the top of the ear, the length of your head from front to back, the size of your ear, the size of your nose, the length of your nose. He's looking at all of these unique characteristics, and he develops a database with all of these characteristics. His idea was, if I can get a database and there's a crime committed and I can get a series of features that a witness can say he had a very big, broad nose. Well, he's got the database. He can go back to that database and say, all right, here are the 300 people I know with big, broad noses. And then, the witness says he had very short, very small hands. But then he can go kind of cross-reference that with, big, broad noses and short hands, small hands. And had a very tiny forehead, all right? Big, broad noses, small hands, tiny forehead. And he's using that database to narrow this down. We don't obviously use this anymore. This is very outdated, but the idea is very much in play. If you can narrow down your suspects by using certain databases, it's going to pinpoint you in the proper direction. Francis Galton, this is huge. There's almost 8 billion people on the planet, and you've got a single set of fingerprints, okay, that you and you alone, maybe there might be one other person on the planet that has your set of fingerprints out of 8 billion, okay? He started the idea of developing fingerprints and how to classify their fingerprints. And we'll spend a lot of time looking at loops and whorls and central pockets and ridges and bifurcations and islands and enclosures. He started all of that in 1892. Leon Lattice, this is important. Every time there's a major catastrophe, they're always asking for, if you've got type A blood, we're low on type A blood, or we need type O, the universal blood type. Okay. Leon Lattice in 1887 to 1954, he devised a simple procedure for determining blood type. So that's kind of a big deal in criminal science. If you've got a blood stain or a pool of blood that might come from two different people, one being the victim, one being the suspect, it might be important to know what blood type it is. You can use that as, again, you're using all of this evidence to narrow down your list of suspects. Okay, so Leon Lattice and his blood typing. Calvin Goddard, 1891 to 1955, okay, using a comparison microscope to detect if a bullet was fired from a specific gun. Okay, this is kind of the father of modern ballistics. All right, if you can find the slug of a gun at a crime scene, and it's probably a 45 caliber or a 9mm or a Glock or an AR-15, you can fire a test bullet from that weapon and then compare that to the actual bullet found at the crime scene, and you could match bullet to gun. That's a big deal. If you've got the smoking gun, no pun intended, if you've got the murder weapon, now you can trace that back to where it came from. Its owner, is it registered? Was it stolen? Who reported it stolen? Who might they have had contact with? Okay, so using comparison microscopes in ballistics is started with Calvin Goddard. Albert Osborne, okay, now we're looking at document examination. We'll look at that. The way that you write your name tells us something about your personality. It tells us something about your psychosis and things like that. It's very unique. But when you're examining documents, the way that someone writes their J's, for instance, for my first name, how I write my J can be compared to someone who's trying to forge my J. Or is the loop too wide? Is it too small? When someone writes their name, some people don't like to write on the line below their name. They want to write above it. So if I'm one of those people who likes to write my name above that line, and then someone forges my name on the line, that's a pretty big tip-off that I've been forged and I've been, someone's trying to steal my identity or whatnot. Okay. So Albert Osborne, obviously in the early, 1900s, anything written could be examined and determined a forgery. Now we can still do this, but obviously we've got computer age now, and we're looking at digital fraud and digital document examination to look for fraudulent documents. Okay, so that's Albert Osborne. This is the big one. Okay, Edmund Locard, 1877 to 1966. Okay, he demonstrated how the principles developed by Hans Gross could be incorporated into a workable crime lab. Edmund Locard is kind of responsible for the FBI crime lab. Every single crime lab around the country, he developed the very first one. His idea was, if all of this science is progressing to help us solve crimes, let's put it under one roof, so I can get all of my biologists studying crimes in one building, all of my chemists in one building, all of my anthropologists in one building, so that when all of this evidence, instead of shipping it all over to different parts of the country, it comes into one place where all the experts are, and we can go through this and analyze the evidence and be more efficient and be more correct in our answers. Another thing he's famous for, and this is pretty much what forensic science is all about, it's called Locard's exchange principle. Okay, this states that once contact is made between two surfaces, a transfer of material will occur. This is what forensic science is all about. And it doesn't matter if it's a shoe print, a paint scraping, an insect. When two objects come in contact, there's an exchange of information, which basically means that when a suspect injures or harms or murders a victim, there has to be a transfer of material from the suspect to the victim. It's our job to find that transfer of material. It's our job to analyze it, and then it's our job to communicate it in a court of law. Okay? So everything we talk about, there's got to be an exchange of material, and that's what we're searching for, and that's what Edmund Locard was trying to tell us. All right? So that's some of the brief history here. Last thing I want to talk about is just what is our function as a forensic scientist. Okay? Number one, there's three things. Okay? Number one, we have to be specially trained to collect the evidence. Okay? Proper training in recognition, collection, and preservation of evidence is required so that a forensic pathologist, a medical examiner, or a coroner can determine the cause of death via an autopsy. Okay? Remember, there's two sides to a court of law. There's the prosecution, which includes the prosecutor, the forensic scientist, and the medical examiner, and then there's the defendants. If we properly recognize, properly collect, and properly preserve all of our evidence, then the coroner can properly do their job. That puts a lot of pressure on the defense attorneys to prove our evidence wrong. Okay? But if we're not doing our job properly, if we don't collect if we don't recognize all of the evidence at the crime scene, we don't collect it properly, we don't preserve it properly, the defense attorney is going to pick us apart and basically have all of our evidence thrown out and we can't use it. That actually helps his case. Okay? So we have to be experts at recognition, collection, and preservation. Once we have it, now we have to take it back to the lab. Now we have to analyze it properly. Okay? We must be skilled in applying the principles and techniques of the physical and natural sciences in order to identify the many types of evidence. Okay? So it goes back to one of those earlier slides. The chemist, the biologist, the physicist, the ballistics, the arsonist. Okay? All of these experts in their field have to analyze the data properly, or else the defense attorneys are going to pick it apart. Okay? And then finally, once it's all said and done, once it starts going through the court cases and we go to court, okay, you may be called to be an expert witness. Where did you find the evidence? How did you collect it? How was it preserved? Did it follow the chain of command? Was everything sealed properly? When you went to the crime lab and you unsealed it so you can analyze it, was it sealed back up? Okay, you're going to have a very unique set of skills for your skill, for your knowledge, to determine in a court of law what actually happened at that crime scene. Okay, so again, we've got to be expert at collection, recognition, collection, and preservation, analysis, and then expert witnesses. All right, so I'm going to stop there. You have this, the rest of this Google slide is for you to fill out. Okay, when you read through the text, there's a section on crime labs, okay, about the history of crime labs, probably starting with Edmund Locard. The next slide is 5 facts about the organization of a crime lab, how are they organized into the individual units. And then the last one, you may have to add a couple slides here. What are the 14 basic functions of a crime lab? Okay, so as you read through the text, they're highlighted in black bold letters. I want you to write 2 quick descriptions of each basic function. And we're going to talk about most of them throughout the semester, but I want you to write them down as well. All right, so you've got your work cut out for you. Watch this video, complete the rest of the Google slide, and then